what Jeff certainly illustrated is that the whole issue of reasoning in AI is very strong. It has been with AI from the beginning. It was a little bit under attack in the 90s, but it is certainly still one of the major research areas, and especially logical, deductive reasoning is something which is studied by a lot of people and taken seriously by a lot of people. So let me discuss here why I believe that too much hope has been and is being placed in this notion of reasoning, especially inferential or deductive reasoning, in a very broad, not too technical sense of the word. My arguments come mostly from cognitive science, and I think they go, or I hope they go beyond the discussion of symbolic versus statistical AI in the 90s, insofar as they draw on more recent developments within evolutionary psychology. There are two ways in which evolutionary psychology has cast a more doubtful light on the notion of reasoning. First, a functional argument. There's a great article by Hugo Mercier and Dan Sperber in Behavioral and Brain Sciences earlier this year called "Why Do Humans Reason? Arguments for an Argumentative Theory." And these authors state that reasoning is not really the kind of general problem-solving device which the brain draws on whenever it has to crack a really hard problem in life. Rather, our capacity for reasoning evolved relatively recently and for the rather narrow purpose of preparing us and enabling us to participate in argumentation with others, to convince others, to manipulate them rhetorically if necessary. This, according to the authors, explains the many systematic biases which humans display in argumentation and which philosophers like to call fallacies. Reasoning can, of course, be used for other purposes and is being used, but it is certainly not the jack of all trades which some proponents make it to be, according to these authors. And the key point here is that it evolved for a narrow purpose and that it is like in the kinds of things it can do, it is limited. A second argument, this is a more computational argument. In evolutionary psychology, there has been a very important discussion in recent years about the evolution of cognitive modules. As you all will undoubtedly know, cognitive modules in the brain are to some extent arealized. That's why we can speak of the brainstem being more involved, more associated with one thing and the temporal cortex with another thing. Now, here's a question. If organisms in a species are confronted with a new ecological problem that requires cognition, what kinds of paths does evolution usually take so that later organisms end up having the new capacity? For instance, you live in an environment which is suddenly populated by spiders, and these spiders are poisonous, just imaginary. How does your brain prepare you for spider avoidance? What path does evolution usually take? And the key prediction within the field has been that stable information patterns, that stable problems with stable information patterns tend to be solved by domain-specific modules. So if there's something very recurrent in the new problem you're facing, for instance, spiders always look very similar. They look small, 8-legged, they run around in a certain way, as opposed to being any object imaginable, you would expect a domain-specific device to evolve which is attuned to recognizing these patterns, 8-leggedness, these movement patterns, and so on. Now, reasoning, if it is a cognitive module at all, which is unclear, is certainly domain general. That's the whole point. And that's just as you would expect if reasoning evolved, in fact, for the purpose of argumentation, because argumentation involving two people is inherently unpredictable. They try to outsmart each other. They try to be unpredictable. But that is not really a good prototypical case for the kinds of ecological problems we often face, which do display a high level of recurrency in the information patterns. Recognizing another person's face, determining if another person is attractive, processing speech, learning to walk, and so on and so on. All these are problems that are very complex, but the kinds of information patterns you have to process in order to deal with them are nonetheless highly constrained. So the prediction within the field of evolutionary psychology has been that such problems are solved by domain-specific modules, and so they cannot be solved by reasoning. Now let me give you an example from my own research where this prediction has practical relevance. I'm interested in communicative comprehension. How do we understand a speech act or a gesture act? The classical answer to this question has been, surprise, we use reasoning. The classical answer, I mentioned that briefly in my introductory talk here 2 months ago, is that we understand, for instance, a pointing gesture by figuring out what the other person wants us to believe by doing this gesture. So you point, and I think you want me to believe that you need the object pointed at, for instance. And if this is true, if we need to engage in this recursive meta-reasoning at third, fourth, perhaps even fifth level when it comes to irony and such things, then yes, the process would be something like, or it would be rather similar to something like what has been called reasoning. But if you think about it, many kinds of communicative interaction, many kinds of speech acts or gesture acts that we process routinely in our daily lives are highly recurrent. Of course, we sometimes engage in deep, unpredictable discussions, but we also point a lot, we gesture a lot, and we do this in contexts which are highly predictable. And this is exactly the kind of problem which you would expect, as explained before, to be solved by domain-specific modules. Take the example of a hush signal. I do shh. That is a communicative act. That is something chimpanzees do not do, that lions do not do. It's species typical and largely species unique for us. How is this understood? Well, unless you are concocting a very elaborate example where a group of New York hipsters sit in a bar and one of them uses a hush signal in order to reprimand the other for saying something politically incorrect or so. A hush signal is simply a request for the other to either stop talking or not continue or not talk at all. And this can conceivably be processed without any recurrence to context at all. You could have a simple decoding device in the brain which just draws the conclusion, okay, he wants me to stop speaking or not speak at all. As a more complex example, think of two kinds of pointing. I point at an object in order to get the object, or I point at the object in order for you to realize this object. This is something which depends on surface features, on available information, for instance, about the object. I am more likely to want an object I point at if this object has some kind of relationship to me, if this object is something I need, and if you know that I need this object. I'm more likely to point at it in order to inform you about this object if you have some kind of relation to it, if you want it or if it is something you currently need. And this is something which can be present in the surface information structure of the situation, which does not necessarily involve social meta-reasoning. And so the prediction is that many kinds of cognitive processing, of communication, rely on such surface patterns and do not involve reasoning. This is the kind of question I'm or the kind of modeling I'm engaged in right now here at the center, and which is, of course, not really compatible with the older approach to reasoning in communicative comprehension. Thanks.